Okay, now we're going to be continuing the 6D video on fractions with radicals, and we'll flip over to this side. A perfect nth power is something where when I take the square root of 2 squared, so the square root of 4 is 2, I get the same number back. The cube root of 2 to the third is 2. The fourth root of x to the fourth is x. These are perfect powers because I can simplify them totally and be left with no radical. So the fifth root of y to the fifth then would give me y. And the cube root of y, it's going to give me 5x. Well, it's going to be 5 cubed and x cubed. So the cube root of 5 cubed is 5, and the cube root of x to the third is x, so that's 5x. And here, so now what we're going to be doing is we're going to think, what is it going to take to make a perfect cube? So here I have the cube root of x. So in order to get the cube root of x to the third, this needs to be x to the second. So now I'm going to have x times x to the second is x to the third, and the cube root of that is going to be x. So here on the fifth root of y to the second, what do I need to make that be perfect inside the radical? Well, I have 2. I need 5. So I'm going to have to multiply by y to the third so that I will then have y to the fifth, and the fifth root of y to the fifth is y. So these are called perfect nth powers like this. So rationalizing a denominator with a radical that is a cube root or larger is different from doing it with a square root. A little bit more complicated. You must multiply both the numerator and denominator by the radical that makes the denominator a perfect nth power. So you're going to have to determine what does the radical in the denominator lack to be perfect, and then multiply the numerator and the denominator by this radical. So example 2, I have 1 over the cube root of 2. I have this radical that I can't reduce or simplify. So I want to multiply it by another cube root in order to make this perfect. So I want to end up with a cube root of 2 to the third right there. So I have 1, 2. I'm lacking 2 more, and that's going to give me this. Now I need to multiply by the clever one. So the same thing in the numerator. So the cube root of 2 squared. And I'm actually going to write the cube root of 4 right there because those are the same things. When I multiply 1 times the cube root of 4 is the cube root of 4. And then cube root of 2 times the cube root of 2 squared is the cube root of 2 cubed. Perfect. So it's going to simplify to be 2. So I get the cube root of 4 divided by 2. Example B, again I have a square root of 2, but it's a fourth root. So I need to think, what's it going to take to make it perfect? Now this time I have the index of 4, so I'm going to have 2 to the fourth. So I have 1 here, so I'm going to require 3 more right there. And then in the numerator, I will write the fourth root, and I'm going to go ahead and multiply it out and put in 8 right there. So when I multiply, I get 6 times the fourth root of 8. And in the denominator, I'm going to have the fourth root of 2 to the fourth, which is 2. So numerator 6. And you may think, can I simplify the fourth root of 8? No, because the smallest number that I have that's perfect would be 16, and it won't go into it. So I get this. Oh, but look here, those two things reduce. So I can divide both of those by 2 and get 3 fourth root of 8 for my simplified answer. And then C, again, you can see my denominator. I have a radical, and I cannot have a radical in the denominator according to my rule. So I have the cube root. So in order to make that denominator perfect, I'm going to have 2 more of those. So that means put the same thing in the numerator, 3 squared. I'm just going to go ahead and write a 9 there. Then that's going to give me the cube root of This time the 2's inside, so 2 times 9 is 18. Divided denominator, that's going to be the cube root of 3 cubed, which is 3. And then cube root of 18. All right, so run through. You might just run through your perfect cubes, which are 8. 3 cubed is 27. Nothing goes into that. And so this is my answer. All right, I know this is not easy. I know it. But I want you to do these things. I want you to try them. I want you to think, what do I need to multiply this by to make it perfect? Do the same thing in the numerator, and then try multiplying and get it. So when you come in tomorrow, next class, I want to see what did you try, what you think you needed to multiply it by, and what did you end up. These answers are weird. You're not going to feel comfortable, but you may surprise yourself, and you may really know what you're doing, but you won't know until you try. After doing those, I will have one more video to go through. So go ahead and work on those and then check back the next video.